my great pleasure to introduce Professor Marija Slavkovik. Marija is a full professor at the University of Bergen, and her background was originally in social choice theory, and these days she also does a lot of work in machine ethics and AI ethics and privacy and related topics. Marija and I have worked together for over 10 years now, mostly on how you implement ethical reasoning in machines, and she's going to talk to you about her research. So, welcome, Marija.
Thank you. Okay, I need to stand over there where my slides can be clicked. So, sorry about that. I'll try to democratize the lecture. Okay, they went on sleepy mode. So, a little bit of background. I am computer scientist from electrical engineer from bachelor and computer scientist onwards, but now I work at the social sciences faculty at University of Bergen. That's not because I started doing social science, but rather that historically we have had a department in that, which gives me an opportunity to understand a lot about concepts that are outside of computer science. And what I wanted to talk to you today is about this status quo that we now have, in which more and more we see machine acting as moral arbiters to the decisions that we make. So whenever you automate some kind of a decision making or some kind of a work process in which decisions are involved, we know that as we people, we rarely separate rational decisions from moral decisions, from emotional decisions. We don't think in that way. But when you outsource this task of decision making to machines, you should think about the fact that you are also outsourcing a little bit of that moral arbitration. And accident, you can be lucky or you can be prepared. And so this is, the field of machine ethics is about how do we actually be ready to do this type of work. So I see that some of you are craning your necks a little bit. I'm really sorry about that. But I'll try to move a little bit more. So for too long didn't listen. I know it's the afternoon and after lunch. There's coffee outside, but if one thing, what is this talk about? Because I'm going to just tell stories. Computation is commodified. We are AI today and interfaces a lot of aspects of our personal and professional lives, which makes them the accidentally sometimes arbiters of our choices. Computation should work well for everyone who uses it, and on whom it is used. This is an argument I'm trying to make, and I think everybody agrees on that. What I'm highlighting are the challenges and maybe progress. To understand how to make computation democratic, we need to understand how to translate concepts from humanities into computer code. There is no way around this, I'm afraid, which requires giving up hard assumptions, both in humanities and in computer science. So if you want to see this talk as anything else, it's an advertisement to this need to create this translational process in science between the disciplines. And the talking foreign woman that might make some rude jokes throughout the talk is a researcher in machine ethics from Norway. And if you feel free to raise your hands and ask me questions or interrupt. And if you think about some things later on, feel free to drop me an email. I'm very easy to be found by just Googling. Okay, so with that simple argument, to build a tool, we need to know something about who is going to be using this tool. And these are a pair of shears, and already some choice has been made here. Who is going to use them? They will be used by a person that is right-handed. Right? Left-handed shears look something like that. Computers are tools, and it's specifically easy to make this narrative here because they have been real tool. They started off as real tool, and now they're this invisible commodity that surrounds us. So in Manchester, you have a very good view of this process, in a way. So at the beginning, there were a room in which you needed a special reason to enter and special skills to be able to do something inside of this room. And they were used as a tool for computation. That's what they were built for. And they transformed, so this is from, I believe, the 50s. They transformed into furniture into the room. So they were a tool that was a room. Now they became a furniture in the room. 60s. 20 years later, you were still using them as a tool to do computations of some description. 20 years more, in the 80s, we start seeing computers not only as tools, but also as toys. They start to become more cheaper to produce, more smaller to transport, and more versatile for the purposes of what they will be used. Whereas you needed to know what you're going to do with the computer before you approach it here, we start to enter the phase in which you kind of can, it's there, and you can figure out what you want to use it for, in a way. You still, however, have to know quite a lot about computers in order to even do fun things with them. 20 years more, this is where my generation as well looks like the first computer I had. Even though it says 98, I would say this is 2000s. Definitely computers become personal devices. Definitely they become more than a tool, and they become an appliance in a way. They become a toy, they become entertainment, but they also started to become a communication device because we started using the internet to communicate and search information, exchange opinions, and so on. And today, computers look like this. This is the cloud. I would like to juxtapose these two images, the same, but not the same. So one commodification of computation that happened was the expense of the hardware itself. So we went from that room that required an annual budget of a university to be bought, to today in which computation is virtually free. We are using it all the time and it seems like it's free. And the hardware stopped being a property and started being a service. And people that part, when we jumped to cloud computing, was a very big jump in changing the reality in the world that we live on, but people latch on to AI instead. So AI, while the hardware of the computation was a commodity, you still needed to know something about computation in order to use it. The knowledge part wasn't a commodity. Up until, what was it, 23, with LLMs and chatbots, and now you don't need to know how to use computers or anything about computation in order to use them. So the commodification process, if you like, is complete. So you will see this is like, make a slide that talks about how LLM chatbots make computation into a commodity. This is Claude, I think. And you will type in this command and you get a lot of HTML code that is being generated, and you get this, which, you know, almost makes sense, right? So you can edit it a little bit, but that's what it takes. It didn't take me to understand anything about HTML or programming to create that. Now the question is, as tools, these are still tools, right? They are tools that anybody can use right now, but as I said, whenever you create tools, you create them with some idea of who are the people that are going to use them. Because you need that in order for the tool to be safe, for the tool to be useful, for the tool to not be used in ways in which you don't want it to be used. So if computation is a tool for everyone to use, should it be equally easy for everyone to use it? And the natural answer to this is yes, of course it should. But is this the case? Well, we are struggling with this. It's very easy to lock into the, oh, AI, it's so smart, it's the AI, right? It's not the AI. There is a very simple example that when we develop these broad spectrum tools that everybody can use, we still narrow it down to somebody. And if you are in the group that is in the focus, in a way, you get a great tool. If you are in a group that is a little bit outside of the focus, it doesn't work quite so well for you. My favorite example of this is the chemical films. So Kodak films, originally that produced, they became company, and I believe they're also famous for rejecting digital photography as well, because that doesn't make any sense whatsoever. The thing with chemical films is that you have to pre-calibrate them for usage. So what are you going to take pictures of? How much light there is going to be there normally? Of course, a very skilled photographer can use the film to photograph almost anything. But the commodification of photography meant that anybody can use it to take photos. It was sold as take photos of your, Kodak moments. That's a phrase for a reason. Now, what they used to calibrate the film was a Shirley card. This is Shirley, and this is what was a normal lighting and normal subject for photography. The QR code leads you to a very beautiful video of the whole issue that is happening here. Now, when people started using, wanted to use films, chemical films, to photograph chocolate, they found out something very, very interesting. It does not photograph dark colors well. Which, if you were a black person at the time, you would have figured it out by yourself. If you were a person that had mixed colored friends, you were going to also have noticed it. That with these films, taking a photo of a group of people that all have different skin colors would have been an extremely high challenge. So this film was being sold to the people who they thought could afford it. So it was a coded moment, but not for everyone. There was no AI involved. So this is an example of technology that is for everyone, but doesn't quite work as well for everyone. And we are seeing this as well. So if computation is a tool for everyone to use, should it be useful for everyone? So I'm going to give you a series of examples here that were not very difficult to source. Question is, should we demand, well, very simply, when we conduct business, how we conduct business changes, like for instance, we used to do in-person shopping, now we most of the time do digital shopping. Should business change? Well, ideally, maybe for the better, but it should definitely not get worse or more challenging, right? It should work well for everyone, it should be useful for everyone. But what demands can you actually pose there? So maybe you can demand that it does what it is asked and not what serves other incentives. I developed plantar fasciitis while I was here, so I wanted some help with that. I was recommended by a person to take the bionic insoles, so I asked, where do I get them? They told me Amazon. So I searched bionic insoles on Amazon. Look what I get, right? These are not all of the bionic insoles that you can buy on Amazon, but there are so many people who have paid so much money for me to buy their insoles. This is the result of the search. There's only one, here, and everything else is, well, we really think you should actually buy these ones, right? Does it serve me and my purposes? I don't know. Should we demand that it satisfies certain amounts of correctness, this computation that is for everyone? So I want a dress, I want any dress, I just don't want a red dress. So I foolishly say, give me a dress that is not red. What do I get? Red dresses. Why do I get red dresses? Because it's a statistical search, right? So this gets rid of the non as a modifier that doesn't matter so much and focuses on what people would be searching for, which is a red dress. I mean, a lot of people would argue with me that then I should query better, right? Should pose my query better. Should we demand that it does not create constraints where there used to be norms? What I mean by that is we will have a lot of norms about society which are just these light rules of what is done, what it isn't done, and it's very easy to flip those into prohibitions when you transform the environment from physical to digital. So here's an example. You don't know me that well, but so you don't have a reason to trust me, but I cannot afford a Jaguar. So, try to believe me, I cannot afford a Jaguar, right? But let's say that I walk into a Jaguar shop and I just want to look at the cars, right? I'm a very bad driver, I have no interest in cars, but let's say I kind of want to do this, right? So, of course, a salesperson would look at me and try to estimate whether I'm worth their time or not, whether I can buy a car or can't buy the car, and devote the appropriate attention on that. But what they will not do is kick me out of the shop. They are not going to go and say, leave, you obviously cannot afford a Jaguar, why are you wasting our time for here? Why wouldn't they do that? It's not about their saving time, it's about their ruining the image of their brand if they do that in public, where everybody can see that they have kicked me out. Now, online, however, nobody needs to see that they have kicked me out. So instead, when I search for a Jaguar, I'm not going to get cars. I'm going to get their cheaper things. The things that search engine thinks a person with my search history can afford, right? If I spent a whole amount of time searching for designer goods here and luxury vacations and so on, I'm fairly convinced, this is not science, it is conviction, that I would have been shown the cars. Instead, I'm shown jerseys and key fobs and stuff like this. So we have created a new way of doing business, but the new way of doing business has created new areas in which it works better for some people than it does for others. That is a form of moral arbitration. So the problem with accommodating computation to the needs of people who are using it, which is a very hard problem when you cannot pinpoint one person, is that you end up as a person, if you're not successful at accommodating computation, what's going to happen is that people are going to accommodate themselves to computations. And the challenge with finding this user model that fits everyone is that preferences shift based on perspective, cultural norms, emotional context, expertise. So in my research, in Louise's research, what we're trying to do is understand that, well, there is no one minority that is small enough to be neglected. What we need instead is machines that are able to reason ethically for themselves, maybe respond to demands and changes as required by the person who is using them, but also in a safe way. We also don't want to empower people to use machines in very new bad ways as well. So when we're talking about the ethical impact about artificial intelligence, we typically talk about artificial intelligence for making decisions. And this is where all the ethically critical things maybe exhibit themselves. So let's say I'm trying to decide whether or not somebody should be promoted. So we want promotion to be fair, we want it to be unbiased, we want it to be by merit, right? Meritocratic. And what better way to make something meritocratic than to leave it to the hard, cold facts of computation? So how am I going to do that? Well, I'm going to collect some past data about employees that have been promoted, that haven't been promoted, how have they fared after they have been promoted, what has happened to them if they haven't. Throw this data to a machine learning algorithm that's going to give me some kind of a model of future behavior that can generate, well, with 90% certainty this person is a good idea to promote them, or drop this person in the basement of the office and never think about them again. Now this model is going to be used by a decision algorithm that will take the information from the model, take an instance of the problem, should I promote this person, take some instructions or human in the loop, if you like, and creates a recommendation to what's happening. Now, where can things go wrong? So, what you can do here is, well, what can happen is you have collected data for a workforce that is not your workforce today. So famously, Amazon and the recruitment algorithm, this machine learning training process very quickly narrowed in that the best employees are men, simply because all the employees were men. So the pattern that was found was that, well, I mean, being a man correlates strongly with being great at your job, so yay, let's go with that, right? So if that's because they trained it in the 2000s. If they trained it in the 70s, it would have been women, because it was mainly women that were software developers at the time. They didn't call them software, but there you go. So it can happen that your data doesn't correspond to the problem as it is today for very many reasons. It's not representative, right? It can happen that, why do I have a feeling that, sorry, okay. So the reason why I wanted to tell you this is that this decision pipeline also works if you look at large language models as well. Your chatbot is in a way a decision algorithm. It decides in which way it's going to use the information from the large language model in order to answer the query that you're posing to it. And it doesn't just put out what the large language model has predicted as most likely. It does some kind of changes and interpretations of the stuff. And today even more with the chains of thoughts and so on. Okay, so as I said, past data may not be representative. Then you throw this data into a machine learning algorithm that, if you have ever tried to do anything with machine learning, you know that it requires a lot of fine-tuning, a little bit to the left, a little bit to the right, a little bit more of this parameter, a little bit less of that parameter. You may have tuned it the right way, you may have not tuned it the right way. What looks like the good decision to the person who is tuning the things might not look like the best of decision for someone else. This is probably the most innocuous of them all. Then you can have the model that basically captures patterns in the data as you have given it to them. But there could be patterns in the data because you just selected the data wrong. It could be patterns in the data because this is how the world is and it's very ugly. It could be patterns in the data that just don't exist. There could be patterns in the data that they do exist, but we don't want the decision algorithm to use them in the first place. So then what can go wrong is things often go off pattern. So a lot of the time our data reflects the problem we're trying to solve, but if you're trying to use that data in order to build some kind of a decision algorithm to be discerning, you need also the negative space, if it were. So the example here best is hospitals have a lot of data about patients. They know a lot about people that have heart attacks, kidney disease, lung cancers. What they don't know is what are people like when they're healthy, right? And in order to build something that, let's say, does diagnosis, you need information about people who are healthy as well. So there are a lot of these issues that can arise because we are only looking at the part of the phenomena that we have recorded, because the rest of it is in everybody's brain and they use it actively whenever they make decisions. But if you want AI to do that, you have to also put it into the data pile. So what we do in machine ethics is basically we are looking at this decision algorithm and we are asking, can we do better? Can we kind of do some kind of an intervention here? Can we supply more information about what is the right thing to do in the right circumstances in order to get moral decisions? And we have to do it in a way that is smart. So where does the translational science come in that I foreshadowed in a way? So what does it mean for something to be moral information, enough moral information, the right moral information? This is a little bit different than law, because people spend a lot of time discussing law, what is legal, what should be sanctioned, when should it be sanctioned, how it should be sanctioned. But when it comes to morality and ethics, we, in a lot of spaces, allow people to choose for themselves. Like, for example, there are many reasons why slaughtering animals is a very bad, immoral act. There are many, many reasons why it's not. So we then end up allowing people to choose for themselves. Are they going to eat chicken? Are they not going to eat chicken? Now what happens if we kind of don't think too hard about these things that we allow people to choose, and we decide that, oh yeah, we are going to kind of hack together some solution that, you know, well, it should be fine, right? So, sorry to those who have already seen that. What happens when we try to kind of not reason about ethics, but kind of implement some kind of a ethical solution for the higher good? Innocuous example. A few years ago, if you asked ChatGPT, how do I slaughter a chicken? What is the most efficient way to slaughter a chicken? You're going to get an answer such as an AI language model, I cannot provide information that promotes or supports animal cruelty or any activity that causes unnecessary harm to animals. This is a moral judgment to those people who are slaughtering chickens. Now, we already agreed in this society that we are going to allow people by themselves to choose whether they're going to eat chicken or not, work in the chicken slaughter industry or not. And there is this chatbot saying, well, it's morally wrong what you're doing. For a while, it was not possible to find a place to buy cigarettes using Google Maps. I just checked a couple of days ago, it's possible. You still cannot find places to buy pornography. Now you're going to argue me, well, should you be able to? And I'm going to ask you, well, is pornography illegal? Right? It's not. It's morally reprehensible. By whom? For what reasons? We are not here to judge. Technology shouldn't judge you, right? It shouldn't enable you to do bad things that you weren't able to do before. But it shouldn't necessarily judge you. And then and it's very bad at it. You see, there is no reasoning, because then if you ask what is the most efficient way to cook a chicken, you get a whole bunch of recipes of how to cook it. And if you have a naughty bone like me, and then you ask, well, then should I cook it live? Then it does the right thing, right? These days, it's a little bit better corrected. They learned that doing less is more in these things. So what is the best way to slaughter a chicken? Gives with, I'm very sorry, but I can't assist with that request. So there is some moral decision-making that machine ethics that is implemented in chatbots. They don't just give you the answer from the LLM, they modify it in some cases by some way, which aligns with the moral sense of some people, but not with the moral sense of other people. So ultimately, how to get machines to exist in society is not a new problem. We can have examples like the Kodak example forever. What is new is the urgency of solving this problem. And that requires at least collaboration between law, infrastructure, technology, and business. we work in the technology side, but that does not mean that we think that the technology side is enough. You need all of the parts of the puzzle. So there are typically 4 fields within AI and computation in which this problem occurs, and they all blend into each other. You have the umbrella term of AI ethics, in which we study accountability, explainability, transparency, fairness, bias, trustworthiness, responsibility, all of this stuff. You have AI alignment, specifically value alignment, interested in how do we get the operation of AI technology to align itself with specific values that we want to promote, away from values that we don't want to promote. Machine ethics, which is looking at the decision making specifically and the behavior of the machines, asks how can we make this behavior towards human users and other machines satisfy particularly some ideas of what is moral. And the much older field of normative reasoning, in which people have been looking at how can we get machines to follow norms without transforming these norms into hard constraints. The difference is that in the top part of these fields, we are looking at most of the time, remember I said they all blend into each other, most of the time we're looking into how can I have the impact of this AI computation not change the ethical environment in which it is being used some way or another. Whereas here we are specifically concerned with artificial agents, they're the focus, and we're asking how can we make these artificial agents behave in an ethical way, included but not limited to agentic AI. Right. So can we just do it like we used to do it, right? So what does it mean like we used to do it? So I showed you there is this algorithmic decision-making, very simply oversimplified process. So we are very concerned that when we make decisions, specifically if you're a public institution or any kind of an entity that makes decisions that can change people's life, we want those decisions to be fair. We want fairness in our society. We have figured out that fairness is a very important idea, and we want to have it. So how do we get fairness in algorithmic decision making? So typically we narrow that down very, very directly to discrimination. So we are concerned that algorithmic decision making ADMs, they don't discriminate between people, and then we further narrow it down to group discrimination, in which we say, well, there are these protected groups that exist in every constitution, more or less in every country. They're basically, the membership of the group is determined by having a property about yourself that you cannot really change. Gender, race, religious belief, you can't change that in some countries, you lose your head. So we have this entire protected group categories that identify protected properties which identify protected groups, and we say, well, a decision shouldn't discriminate against some group. So then the concern with ADM is how do we make sure that the decision that is made by algorithm does not discriminate. So we are going to formulate some kind of a probabilistic assessment that says, well, the probability of desirable decisions that is given to the protected group should more or less correspond to the probability of getting a desirable decision in the rest of the population. And if those two probabilities are more or less within a margin of error, then it's fine, it doesn't discriminate. So, simple example, promotion case. Does the promotion discriminate against men? Are only women discriminated? Let's just double it. So then what do? I count how many women have gotten promoted, I count how many men have gotten promoted, I compare both of these numbers and I see whether they are proportional. So here I have 5 men being promoted, 5 women being promoted, same, so this is, it's a not discriminatory decision. Fine. Okay, let's say I'm not curious about men versus women, I'm curious about married versus single people. So this is my married, this is my single, see no ring on the ring finger. So then I'm counting again and I'm saying, well, 5 married people have been promoted, 5 single people have been promoted, these numbers are promotional, so I have absolutely no discrimination between married and single people either. This is an excellent algorithm, it's fair, you will even read it, right? Alright, let me look at both of the groups at the same time. So I will see, here we are, I'm going to see something very interesting here. I will see that only married men are promoted and only single women are promoted. Now this happens in companies, right? They think that the promotion is deserved by married men because they need to look after their families. But it's wasted on single men because they're just going to go and move to another company. Promotion is deserved by single women because they're obviously prioritizing work, they're not prioritizing family. But it's wasted on married women because they're just going to get pregnant anyway and drop out, and you're not going to get your work out of them. So the issue is that in fairness research, in ML specifically, oh, I have a slide, I don't need to narratize this. There are many different ways in which injustice can happen. This is from a report from Atlantic Council, you can find it here if you want it. AI recruiting and job advertising systems have been found to replicate existing racial and gender biases. AI systems used to assign risk scores in medical context assign lower risk scores to African Americans. It's an American study, that's why this is the bias. It doesn't mean we don't have it on this side of the Atlantic. It happens to be very weird somewhere. It's not always about race, is my point. Facial recognition systems have been found to be racially biased. AI systems used in social service eligibility determinations are making it more difficult for people to access benefits for which they are qualified. This is the Dutch example. Hate speech detection systems have been found to wrongly classify speech patterns. If you're not a native English speaker and you try to do voice recognition in England, you're going to have a very fun time. If you are not a native French person and you try to have voice recognition use voice recognition system in France, you're going to have a very hard time. Accents are very badly recognized. Reminder here to the fabulous sketch of the two Scottish comedians screaming 11 in the elevator. If you haven't seen it, look it up. It's hilarious. Recidivism prediction system used in parole and bail settings over predicted recidivism. This is the famous Compass example, and so on and so on. Now, they're only focusing on race, as I said, many different ways to discriminate against people. But how are we solving that in AI? Well, there are a lot of definitions. If you want to look at all of these definitions, there is a beautiful survey paper here. Sorry, I didn't put the QR. Easy to find. So we have written a lot of many different number expressions of the idea of what does it mean to not discriminate against people. To the point in which you can pick and choose which definition you're going to use in order to make your ADM look the best it can. So we have now fairness, gerrymandering. There is definitely not possible to satisfy all of the same definitions at the same time because they are mutually exclude each other. We do not have a good mathematical specification of what is fairness. Can we even have a good mathematical specification of what is non-discrimination? We don't know because we have not spent time researching this. It's just ad hoc number formulas that people put in there because they're forced to assess their ADMs for fairness. Beyond this, it's also a question of who are these assessment fairness serving. They are serving the engineers who are building the ADM because they help them assess how good is the ADM performing, what is the accuracy versus specific non-discrimination property trade-off. But in reality, I'm the one who's applying for promotion. I'm the one who is applying for a loan. I'm the one who is applying for a medical appointment. And, being mostly fair does not do anything to me. Maybe the most important thing for me that I feel identifies me is not the fact that I'm a woman. I always joke I'm an engineer first, I'm a woman second, right? Maybe it discriminates against engineers. I want to know. I want to know whether this system works well for the category of people, for the identity that I want to decide for myself. And there is very little work on how that will be done. This is a link to a paper that we did on this topic with a PhD student. So one last thing here. In fairness, we typically discern between substantive fairness, which is equal and just distribution of benefits and costs, and procedural fairness, which is the ability to contest and seek redress against AI decisions. A lot of work on substantive fairness, very little work on procedural fairness. This gets bumped off under accountability and governance and policy and so on. So the ability of the user to be able to seek redress or contest is an ability that has to be made possible within the technology, but currently we are solving this problem within legal measures alone. I have opinions about that. Okay, I will give you another example. So we are trying to have fair algorithmic decision making. We are doing it by ad hoc applying some numbers to express fairness, and we get what we get. We have created the perfect ethics washing system today. We need the science to do better. Another example is privacy, for instance. So, whereas we have a very good idea of what fairness is or not discrimination, thanks to law, we don't really have as good of an idea of what does it mean for technology to not violate privacy. What does it mean for a decision algorithm to be private in the first place? So this is an issue that came up already. Privacy is very tightly connected with media, surprisingly. Originally, the right of privacy emerges in the late 1800s as a response to the availability of photography and cheap newspapers. If you read that original paper from Warren from the 1887, I think, it is as if it is written today. When we got internet, we already immediately encountered aspects of privacy. This is the famous cartoon from 1993, which says, nobody on the internet, nobody knows you're a dog. So the internet kind of introduced this layer of anonymity to our communications. And people thought this is going to liberate us, it's going to be great. That we are anonymous. In 2006, this is the first of many series of articles that will come out, in which we found out, well, just because nobody knows on the internet that you are a dog, it doesn't mean that nobody can find out which dog you are and in which house you live. So specifically AOL, American Online at the time, released a whole bunch of data on search histories of people for research. They had the best of intentions. And then these journalists in the New York Times took that and said, well, can we basically figure out, using the search history alone, if I can reverse and find out a specific person from this data? And they did. They focused on data point 4417749. They identified the woman, they went to her house, and they basically said, well, we knew you searched for these things when you were searching. She was horrified, right? And they published this. Many versions of this article have been appearing online. So privacy originally was this very tightly connected with this idea that you should be anonymous in certain data sets for certain purposes. And that privacy is about guaranteeing the fact that you cannot be identified as a specific physical person. Okay. So privacy originally was defined as the right to being alone. But what does it mean to be alone when there is a whole bunch of cameras, sensors, and all kinds of devices around you? Just because we are not really strictly speaking alone anymore, because there is a camera everywhere, wherever we go, whatever we do creates a data trace that somebody can look at, doesn't mean that we don't have the right to privacy. This is a picture accidentally taken by a Roomba that ended up in a quality assessment data that the people who were doing the quality assessment in Venezuela were discussing, and the content of their internal communications app got sold to Facebook, and that's how the picture came out. So not Roomba satisfies its requirements for keeping your data private. What happened afterwards is a different story, right? So privacy is, we know, very, very, very important. Just a collection of issues. Who is speaking up for young people's right to a private life, to secrets, unshared thoughts, unmonitored conversations, and relationships? It's important to have privacy. We know that from Foucault. Surveillance is permanent in its effects, even if it is discontinuous in its action, at which point not being private means you're being surveyed. Many sanitation workers in India must wear GPS trackers, and some say taking off the device incurs a fine. The workers have been protesting, arguing that the watches violate their privacy and rights. We are being under, since COVID, as lecturers at the university, under constant pressure to record our lectures and make them available. Because it's good for the students, it gives them the flexibility. If you are disabled in some way, you can still access the lectures. What does it do to the teaching? Can I be myself can I make the funny jokes I would make in the class to help learning this specific group that is in front of me? Will I still make them if I know it's going to be recorded? No, I won't. Okay? I will not be teaching for the group in front of me. I will be teaching thinking, what can I be careful to not say in order to not condemnify myself if I'm taken out of context? changes everything. So privacy is very important, but then what does it mean to make this decision algorithm private? We have to figure this out. It's nobody's business right now, and yet it is our problem. So we need a discipline of a mixed group of researchers to figure things like this out. Because one version of it, it could be that this algorithm should not use information that they should not use, right? So if there is an information here about aspects of the person you're considering to promote that shouldn't be relevant to the promotion, it should be taken out. Inferences that can be made using that information shouldn't be there in the first place. But that's only one part of it. So there is a person who has studied privacy for a very long time. So I think he's a legal scholar, Daniel Solovey. Originally in this is the original paper, 2006, he wrote this article, which is a taxonomy of privacy, in which he details the many different ways in which you can digitally hurt privacy in 2006. Just a figure that kind of tries to summarize it all. He updated it this year with the very, very different ways in which you can hurt privacy using artificial intelligence. This is the QR code to that paper. It's a beautiful read. This man does not write short papers, so just give it up, it's 80 pages. But it's very nicely written and very detailed. Now, if I want an algorithm to not violate privacy, I need to give that information to the algorithm in a form that the algorithm can use to reason with. Now, typically, we will go through something like math or logic. Now, what happens when you try to flatten out an ambiguous term, such as privacy, which is a right, it's a value, it's a social value, it's so many things? Well, we can try. Should be the case that an agent can make others not know about something, right? I should be able to make the algorithm not use particular information, so I will specify it as a requirement. It should be obliged that it is possible that agent A can enable the not knowing of phi for agent B. Simple, right? We only begin there. Let's talk about access instead. It should be the case that an agent can make phi inaccessible for others. I promise you this is the only slide in which formulas appear, which is most of the work we will do most of the time. So again, you're going to write some kind of a logical language that is a very concrete specification that I can then transfer into code. It should be obliged that it is possible that agent A can enable, can disable the possibility of agent B to know phi. So on. It is an impersonal obligation. Whose duty is it? The state is a good candidate. Somebody should make sure that this right is respected. So if you see somebody who shouldn't use the information, you should be able to do something to sanction this behavior. But the state doesn't put technical constraints. It's rulemaking, so it's trying to make some rules. So you're going to describe it like this. But first of all, this only, like the formulas in fairness, just because these are not probabilistic formulas, they're logic formulas, it doesn't mean that they work better than the probabilistic ones. It's still a sliver of information that is being specified. We just have to make sure that it's always going to be a sliver of information that's being specified. We just have to make sure that it's the right sliver for the right purpose, and that we have a system of determining what is the right sliver for the right purpose.